Students, now question number 5. State true or false for the following relations defined defined on A 1, 2, 3. This is the question. Here first one R1 1, 1, 2, 1, 2, 2, 3, 2, 2, 3 is symmetric. Now what is the condition for symmetric? If it is 2, 1, then there has to be 1, 2, but there is no element has 1, 2, only 2, 1. So we can say that 2, 1 belongs to R1 obviously, but 1, 2 is not belongs to R1, not belongs to R1, which means the first one is false. So I am writing here in the book false. First one is false. 5A. Next student, R2 3, 3 is symmetric but not reflexive. Question is given 3, 3 is symmetric but not reflexive. So students, for the reflexive, we know that A, B, B and C, C belongs to the relation, but here it is given 3, 3 is symmetric but not reflexive. Now look, for the reflexive A, which means 1, 1, then 2, 2, then 3, 3 should be relation to the R2, but here is given only 3, 3. So students, for the symmetric, we know that here 1, 1 not belongs to R2, then 2, 2 is also not belongs to R2, and 3, 3 is belongs to R2, which is symmetric. So it is true. First one, second one is over. Now the third one, C. Look, 1, 2 is antisymmetric. It is given here for R3. Yes, it is actually 1, 2 belongs to R3, but 2, 1 is not belongs to here for the relation. So it is true. This one is also true. Next, number D. Look here, D. There is 1, 1, 3, 2 and 2, 3 is symmetric but not antisymmetric. Yeah, it is actually true, because 2, 3 belongs to R and 3, 2 also belongs to R. So it is true. The D also true. I'm writing here T means true. Number E now. Look here now, number E. 2, 2 is antisymmetric but not reflexive. It is true also, because 1, 1 and 3, 3 is not belongs to the relation. So 2, 2 is only. It is antisymmetric but not reflexive. It is true. Next, number 5, R6. Next one, F, R6. 1, 2 belongs to R, 2, 3 belongs to R. 2, 2 cancel, which means 1, 3 also belongs to R, which means it is transitive. True, F. Now look, G. R7 is 1, 3 and R8 is 2, 2. Both are transitive. No, it is false, because there is 1, 3, then there is no other elements which is satisfy the R7, and there is no other element which is satisfy the R8, which means it is false. The next one is false. Number H now. Here it is given R equal to A cross A is equivalence relation but not antisymmetric relation. Now look, A, A means what? Here A is given 1, 2, 3. A, A means A product A. So obviously it is, if we go for the A product A, which means this will satisfy the symmetric also, which means A, B belongs to R, B, A belongs to R. Then transitive also, which means A, B belongs to R, B, C belongs to R, implies A, C belongs to R. And reflexive also, A, belongs to R, B, B belongs to R, C, C belongs to R. So if we go for the A product A, here it is equivalence relation, which means it is true. The last one is true here. I am writing here true. The number 5 over.